Welcome. Today we are solving nth root and 1 over n power equations. So these are equations that have any type of radical, any what we call index on the radical. And we're even going to see rational exponents in equations. We'll learn how to solve those. We do have to check for extraneous solutions here. If in the past you've solved square root equations, you might recall you have to check for extraneous solutions. You can't put a negative into a square root and get a real answer, right? So we're going to have to do that. Now, that only happens, though, if you have, like a square root. Of course, you're going to get, some kind of imaginary number, so which we're not considering here. We're just we are just concerned with real answers here. The same thing is going to happen if you take like the fourth root. We won't talk about what the answer to that is. That'd be beyond this video. But just it does come out to something complex, non-real. So we have to just make sure that whatever we get for our answer, it works. It's going to give us a real solution. Okay, so any even root, 4, 6, 8, 10, doesn't matter what it is, that same thing happens. You get some kind of non-real answer if you input a negative number. All right. Also, that for when we get to our rational exponents, if we see any even denominators, well, that sort of indicates an even indexed radical. So for those, we also have to check for extraneous solutions. Okay, so let's solve number 1 here. We're going to go ahead and take away 9 from both sides. So we get the fourth root of x minus 1 equals negative 2. And then what we're going to do is actually raise both sides of the power 4. That's going to undo a fourth root. Okay, so yeah, whatever the index here, you're just going to raise it to that power. Just make sure you isolate the radical first. Okay, so we have x minus 1 equals, this is going to come out to 16, okay, positive 16, and then you'd add 1 to both sides and get x here, so you get x equals 17. Now we need to make sure that works. So this is a even index on our radical, so we have to make sure that our answer is not extraneous, so we're going to check that. We're going to put 17 in for x. 17 minus 1 plus 9, does that equal 7? This comes out to 16. And then the fourth root of 16, we're just going to consider the positive fourth root here. So, and on a calculator, to get a fourth root, probably the easiest way I like to do it is just use an exponent of, if you have a fourth root, you could do 1/4. If you had a seventh root, you'd do 1/7. So I'm going to go to the 1/4 power like that. And let's see what we get. We get 2, all right? So 2 plus 9, does that equal 7? No, it does not, okay? So that means this is an extraneous solution, okay? And so what does that mean? Well, that means we have no solution to this problem, okay? Or really, we should say no real solution would be the most accurate way to write our answer. So no real solution on number 1, all right? All right, let's take a look at number 2. So here I have a something of the rational exponent. Now there would be a way to sort of convert that to a radical. I actually prefer on these to just keep them as rational exponents, and I'll kind of show you why once we get to that step. So what I'm going to do here, I need to isolate what's being raised to the rational exponent. I want to isolate that, so I'm going to take away 2 on both sides. Unfortunately, that means I'm going to have to subtract a fraction, a whole number from a fraction. Not too bad, but let's see, we have this, that is a negative 2/3 there. And now this I could think of as, if I want to get a common denominator, this would be 18 over 9, right? So if I'm taking away 18 over 9 from 19 over 9, I'm going to end up with 1/9. So I have 1/9 equals x plus 6 to the negative 2/3. All right, so to get rid of a rational exponent, what you do is you actually raise both sides to the reciprocal power, and we want to end up with basically we want to this exponent to end up as being a positive 1. So I'm going to go ahead and do 3 over 2, but I'm also going to make it negative because what's going to happen is when these multiply each other, well, the 3's are going to cross cancel, the 2's are going to cross cancel, and we have like a -1 times a -1, which is 1, which is what we want. So we're raising both sides to the -3/2 power. So yeah, you basically match the sign, and then you use the reciprocals with the power that you raise it to. And of course, you have to do it to both sides. So on this side, we're just going to be left with our x plus 6 to the first, which we don't have to write that. And then on the other side, let's go ahead and let the calculator do that for us. So we're going to put in 1/9 to the -3/2 power. I guess I don't need parentheses on this. Some calculators you do need to put parentheses in for the power. If it's not showing on the calculator, like if the exponent isn't being raised here, if it's just showing the caret symbol, you do have to put in that the parentheses on the exponent. So I'm going to do this, and I end up with 27. Okay, so we get 27, and then we're going to take away 6 on both sides. And so I get 21 equals x. You actually don't have to check for extraneous solutions on this one because we had an odd denominator. With that translates to, if you think about it, well, it basically translates to a cube root. So in cube roots, you don't have to check for extraneous solutions. You can put negative numbers into cube roots, and they turn out just fine. All right, so there we go. That is our answer there. Okay, let me do number 3. This one, we would want to isolate the radical. So I'm going to add 2 to both sides. And so I have -5th root x minus 5 equals 3. And then we want to get rid of this negative. There is a way you could deal with the negative, raise both sides to a power and deal with the negative. But I prefer not to think about that. I'd rather just divide both sides by -1. That gets rid of the negative, and then we get 5th root of x minus 5 equals -3. Now we raise both sides to the 5th power, and so we'll get x minus 5 equals, and I'll need the calculator for that one, -3. Make sure you put that in parentheses. Actually, it really wouldn't matter, but just by coincidence, you still want to, when you raise a number to a power, you should always put it in parentheses, especially, if it's negative. All right, so -243. And so I'm going to add 5 to both sides and get x by itself, so we're going to get -238 is our answer there. You actually don't have to check for extraneous solutions because we had an odd index on our radical, so all inputs would work, okay? Feel free, you can check your answer, all right? Not a bad idea, but we don't have to check for extraneous solutions. Okay, and I'll do number 4 here. So we're going to take away 5 on both sides. And so we get 10 minus n to the 3/2 equals 216. And kind of like number 2, we're going to raise both sides to the reciprocal power of 3/2. This time it's just positive because this is positive. So you'll end up with, basically a power of 1. If you recall the power rule is what we're using here, the power rule of exponents. Right? If you have an outside exponent, inside exponent, you multiply them. So, and what ends up happening is this just becomes a 1. So you get 10 minus n, and then I'll let the calculator do that for us here. So 216, it's positive, so I don't have to put it in parentheses, to the 2/3 power, 36, and then take away 10. Negative n equals 26 divided by -1. we get n equals negative 26. Now this one we do have to check because we have an even denominator. That would translate to, a square root, which you can't have negative numbers in a square root and get a real answer. So let's go ahead and do that. We're going to do 10 minus a negative 26 to the 3/2 power plus 5. Does that equal 221? So this is going to come out to 36. And then again, I'll let the calculator handle this for me here. So yeah, if you think this is like 36 to the 3rd power, the square root of that. Okay, it's the square root of 36 to the 3rd power is one way to think about that. But I'm just going to let the calculator handle that. So 36 to the 3/2 power, and we end up with 216. And then we add those up, and it works out. So that is not an extraneous solution, so we are good to go. All right.